Right, now let's start looking at some applications of integration. Often these sorts of questions will come up in the external with complex unfamiliar questions, because the whole thing with complex unfamiliar is that it's in an unfamiliar setting or context. Okay, so it's something that you know nothing about, and it's being able to apply the skills that you've learned to something you know nothing about. Okay, so we know nothing about concrete slabs, and they're just telling you a whole story about these concrete slabs that have got tubing in for heating, and basically the number of liters per minute of water flowing through the tubing over T minutes can be modeled by the rule. Now dV by dt, the rate of change of volume with respect to time, can be given by this function: 2 cos pi t on 3 plus sine pi t on 9 plus 3. And if we have a look at that function, it looks like something that we don't know anything about. But if we just follow our rules and not panic, we can work through it. Okay, so it says, what is the rate of flow of water, corrected 2 decimal places? Now this will be a take active question, okay, at 4 minutes. All right, so we're going to say, using our graphics calculator, and we want our rate of change, so the rate of flow, we're just using our derivative function they've given us at 4, okay, will be 2 cos of pi times 4 over 3 plus sine of pi times 4 over 9 plus 3. And let's plug that into our calculator. Remember to make sure that your calculator is in radian mode when you're working with it, okay? So we have 2 cos of 4 pi on 3 plus sine of 4 pi on 9 plus 3. And that gives us 6 point, careful with your rounding, 97. So 6.97 meters per minute. Okay, and then our second one, we want our rate of change at 8 minutes. So that's now going to be 2 cos of pi times 8 on 3 plus sine of pi times 8 on 9 plus 3. And again, we'll just put that into our calculator. So we have 2 cos of 8 pi on 3 plus sine of 8 pi on 9 plus 3. And that gives us 5.68 meters per minute. Alright, now B says state the period of the function. Now, depending on how accurate the graph is, alright, you could have a look at your graph and see, well, it appears to be starting to repeat itself somewhere over there. Okay, so it looks like the period is 18 hours. This graph is not very accurate for that. Okay. Or what you can do is calculate the lowest common multiple of our 2 periods. Okay, because the lowest common multiple of the 2 different cos and sine graphs will give me our period. Okay, so let's have a quick look at that. If we have the period of our cos pi on 3t, remember that period is 2 pi on b, and in this case my b is pi on 3, so it's going to be 2 pi on 3, and that gives me 6 hours. So my period for my cos pi on 3 is 6. Okay, And then when I look at my period of my sine pi t on 9, again my period is 2 pi on b, and that means it's 2 pi on 9, and that's 18 hours. And what you'll notice that 6 can go into 18, all right? So that means I have 3 cycles, or 3 cycles of my cos 1 in that 18 hours. So my period is 18 hours. All right, now it says determine the volume of water that flows through the tubing during the time period for one whole cycle. Okay. That means that if we got our period wrong, we're going to have the wrong limits of integration. All right, so we need to make sure that we know how to find the period of that function, because we're going to be integrating between 0 and 18. Now looking at the graph, that's all above the curve. All right, so we can put in, I didn't have a good 18 there. And put in a value somewhere there and say this is our area. Okay, so our volume will be equal to the area under the curve. That's going to be the integral from 0 to 18 of my function, 2 cos of pi t on 3 sine of pi t on 9 plus 3 dt. Okay, now they haven't specifically said to us that we need to show the calculus or that we have to show all the working. Okay, but I am going to show the integration just to make sure that you're comfortable with your integration. So to get a positive cos, we needed a positive sine, so we have sine pi t on 3. Remember, we have to divide by pi on 3. And positive signs and negative cos, so negative cos of pi t on 9 over pi on 9 plus 3t, and that has to go from 0 to 18. And I can just neaten that up a little bit, so I have 2 times 3 on pi of sine pi t on 3 minus 9 on pi cos of pi t on 9 plus 3t, and that's going from 0 to 18. I think it's easy to multiply the 2 in first, so we have 6 on pi sine of pi t on 3 minus 18 on pi cos of pi t on 9 plus 6t, and that all goes from 0 to 18. And when I put in all my values, I have 6 on pi sine of 18 divided by 3, so 6 pi minus 18 on pi. Cos of 18 divided by 9 is 2, so 2 pi plus 6 times 18, and I'm going to subtract 6 on pi times sine of 0 minus 18 on pi cos of 0 plus 0, and sine of 6 pi will just be 0, and cos of 2 pi is negative 1, so plus 18 on pi, plus, and 6 times 18 is 108. Sine of 0 is 0, so minus 0. Cos of 0 is positive 1, so plus 18 on pi plus 0. And that gives me 108 plus 36 on pi. And this was with a calculator anyway, so you would have just put it in. But I wanted to show you and go through the process anyway. It's 108 liters, so therefore the total volume that flowed in one cycle is 108 liters.